So similar to the previous case, the gap between P1 and P star is the burden of tax on the consumer, and the gap between P2 and P star is the burden of tax on the seller. Okay? Same idea. So we can therefore have a abstract we can now have an abstract formulation of this problem where the original market equilibrium price is P1 P star, S and demand, original market equilibrium, this kind of tax is going to cause a leftward shift of the demand curve. We find new equilibrium at B. P1 is the price that our consumer pays. P2 is the price that our producer receives. P1, the difference between P1 and P star, the difference between P1 and P star is the burden of tax on buyer, and the difference between P2 and P star is the burden of tax on the seller. Okay? Any question? I'm going to get out of my slide and we're going to draw some cases, different kind of situations to highlight the most important question of today. So these were all review of previous class. We want to start our new material today by asking a fundamental question. We have seen that regardless of who pays the tax burden falls on both sides of the market. The buyer and the seller both pays at least some part of the tax burden. So the question is, who pays the larger share of the tax burden? The answer is, it depends. We're going to show that the nature of the tax burden really depends on the shape of the demand curve and the supply curve. The way we are going to look at different shapes of the demand curve and the supply curve are a little bit, sort of unsophisticated, because I just realized today that I should have covered chapter 5 before covering this chapter, because we should have first talked about elasticity of demand curves and supply curve, because the shape of the demand curve and supply curve tells us a lot about the buyer and the seller side. So today we are going to, instead of using these very sophisticated interpretation of the shape of demand and supply curve, we are going to work with less sophisticated concepts like steep and flat demand curve and supply curve. But we will try to get an understanding of what does these means. Okay, so please draw these graphs with me, because it is the more you draw these problems, the better understanding you are going to have about tax incidence, and tax incidence will be in your exam. This is not trivial. Okay, a lot of you will find it very difficult to answer questions in the exam that are going to come from tax incidence. So please try to do as much experiment as possible. The first experiment that we are going to do is, it is going to be a situation where the tax is paid by the seller. Tax paid by the seller. So that's my first experiment. I'm going to consider two different cases. Okay. In case 1, I will have a situation where my demand curve Come on. So that's my int tool. I don't need my int tool. I need. Okay. So in this case, I'm gonna think about my demand curve being a little bit flatter than my supply curve. Okay. So let's oh yeah, something is. Okay, so one seller pays tax. Two cases. Case number one, we are going to have a situation where my demand curve is flatter than my supply curve. Let's imagine that the original market equilibrium price is P star. Original market equilibrium quantity is Q star. This is my S, this is my D. There is a tax imposed on the supplier, so it's going to shift my supply curve to the right like that from S to S1. I will have the new market equilibrium at point B. So at point B, P1 is the price that my buyer pays, and in order to find out the price that our seller receives, I go vertically down to the original supply curve, and P2 is the price that our seller receives. So in this case, the difference between P1 and P star is the burden of tax on buyer, and the gap between P2 and P star is the burden of tax on the seller. Now the question is, who is paying the larger share of the tax burden? Who is paying the larger share of the tax burden? Do we all see that? It should be obvious that the difference between P2 and P star is much larger than the difference between P1 and P star, right? So our seller is paying the larger share of the tax burden. This case is a situation where our supply curve is steeper than our demand curve. What does it mean? It means that if we look at the slope of the supply curves and the demand curves, our supply curve has a larger slope than our demand curve. Other way to say is that our demand curve is flatter than our supply curve. We're going to stop here because in the next chapter we're going to interpret what does this flatness and the steepness of the supply curve and the demand curve actually means for our economics. We need to have an understanding about elasticity to explain that. The second case that we're going to draw is opposite to this one. In this case, we're going to have a steeper demand curve and a flatter supply curve. Again, the original market equilibrium is P star and Q star. And I want to be as accurate as possible. So the shift has to be equal to that amount. So I'm going to try to make it work. So this should look like that. So that is my leftward shift of the supply curve. If that happens, P1 is the price at B. P1 is the price at B, the new equilibrium, and A is the old equilibrium. And in order to find P2, I go to the original supply curve, and now the difference between P1 and P star is the burden on buyer, and the difference between P2 and P star is the burden on the seller. This is the case where demand is steeper This is the case where demand is steeper than supply. Now, who is paying the larger share of the tax burden in case number 2? Do we all see that? This is A and this is B. Do we all see that in this case, the gap between P1 and P star is larger than the gap between P2 and P star? So our buyer is paying the larger share of the tax burden. Let's now make a very important conclusion, which will be in your exam. We notice that in this case where the seller is paying the tax, who bears the larger share of the tax burden really depends on the steepness of their corresponding curve. If the supply curve is steeper, our supplier bears the larger share of the tax burden. If the demand curve is steeper, our buyers pay the larger share of the tax burden. So, conclusion. Tax burden increases with steepness, and I cannot write there, so let's just go down. So, conclusion, tax burden increases with steepness. The steeper the demand or the supply curve is, the larger the share of the tax burden borne by the buyer or the seller. Okay? Is this a general conclusion? Is this true that the steepness always determines who bears the larger share of the tax burden? We have just seen the case of a situation where the tax is paid by the seller. We are now going to go to the other side of the market. In experiment number 2, we are going to consider when the tax is paid by the buyer. Just like the previous case, we are going to consider 2 different cases. In case 1, we are going to assume a steeper demand curve and a flatter supply curve. So you have a demand curve and a supply curve. Original market equilibrium at A, where P star and Q star is the original market equilibrium price and quantity. Now the government imposes a tax on the buyer. When the buyer pays the tax, let's assume that the demand curve shifts like that. If the demand curve shifts from D to D1, we have equilibrium at point B. In order to find the price, so this is the price that our producer now receives. At the new equilibrium, this is the price that our producer receives. In order to find out the price that our buyer pays, we go up to the original demand curve and we find P1. Why do we have to go up to the demand curve? Because our buyer pays this market equilibrium price, then it pays a tax to the government. So we have to go up to the original demand curve to measure the vertical distance change that has caused our demand curve to shift. So this difference between P1 and P2 is the amount of tax that our buyer pays. So now, the difference between P1 and P star is the burden of tax on buyer, and the difference between P1 and P2 and P star is the burden on tax on the seller. The question is, who is paying the larger share of the tax burden? In this case, the buyer is paying the larger share of the tax burden because P1 minus P star is much larger than P2 minus P star. Do we all see that? Do we all see that? So in this case, so let's write down what the case is. The case is our demand is steeper than supply, and we're going to look at the same, the case number 2, where we are going to now think about a flatter demand curve there and a steeper supply curve. We have the original market equilibrium, price and quantity. We need to make sure that conclusion after are identical, which means that regardless of who pays the, so in this case it is true that regardless of who is paying the tax, either it is buyer or seller, the tax burden is really determined by the steepness or the flatness of the demand curve. If the demand curve is steeper than the supply curve, regardless of who pays the tax, our buyer pays the larger share of the tax burden. If the supply curve is steeper than the demand curve, regardless of who pays the tax, our suppliers bear the larger share of the tax burden. This is a very powerful result. Okay? Any question? Okay, so we will now, what we're going to do, we're going to sort of get out of this Word document and get back to our PowerPoint slides. And skip some of the in-class problems that is indicated in the slides. Your SI leaders will have answers to these questions. Please try to solve these. I'm going to give them this answer to these questions, and if you have to, if you think that you are not understanding these questions, just ask them. They will be able to answer your questions. I'm running out of time, so I want to finish this chapter, so I'm going to go ahead. Okay. Okay. So it is very rare that we cover appendix of any chapters. Okay, there will be only 3 instances where appendix of certain chapters become important. This is one of those. Okay? So what we're going to do now is we're going to look at an alternative way of looking at market equilibrium, and that alternative way is a mathematical way of looking market equilibrium. So what we're going to do now is in the next remaining 20 minutes, we are going to look at market equilibrium, everything that we have looked at so far about our market equilibrium from a mathematical perspective. Before I move on, I want to just make a general caution. Based on my 15 years of teaching, I have seen that many of you have a general sort of fear about math, which really clouds your understanding of how some of the mathematical tools can be conveniently used in economics. Math is sometimes your friend. So rather than being scared of the mathematical formulations that we are going to be using, which are very rudimentary, try to understand them. They are very simple. You really do not need anything beyond your 5th grade math to really understand what we are doing here. Now, the starting point of this mathematical way of looking at market equilibrium is that we have so far looked at market equilibrium from a graphical perspective, where we have defined a downward sloping demand curve, we have defined an upward sloping supply curve, and in the interaction of this demand curve and supply curve, we have found market equilibrium, equilibrium price and equilibrium quantity. Now, these downward sloping demand curve and these upward sloping supply curves did not come out of thin air. There is a strong mathematical foundation behind these graphs, right? What we usually do when we think about the mathematical formulation of some graph, we usually resort to this very familiar and very simple mathematical equation that really is used to represent an equation of a straight line. The reason why we do not need to go anything beyond that is because most of the graphs that we use in our economics are basically straight line. What does this equation tells us? The equation tells us that if we have a mathematical equation of two variables, y and x, we can represent the equation of a straight line as follows, where c is the vertical intercept if you are measuring this equation by, where y is measured by the vertical axis, x is measured by the horizontal axis, and the c is the vertical intercept of this graph of a straight line. What does c mean? C refers to the value of y when x is equal to 0. So c basically is called the vertical intercept, which is the value of y when the value of x is 0. M stands for the slope of this function. M really tells us how steep or how flat your curve is, equation is. If M is positive, this equation can be represented, and I just made a mistake. If M is positive, this equation can be really represented by an equation where the equation is an upward sloping straight line, where the small intercept is your vertical intercept c. If M is negative, our equation can be represented by a downward sloping line where c is the big vertical intercept. Do we all see that? So notice that the graphs that we just drawn, a downward sloping graph or an upward sloping graph, they look very similar like to our supply curve and demand curve, right? You see that? Which means that this simple mathematical equation can be used to define a demand curve and a supply curve. So the basic difference between a demand curve and a supply curve is basically that M, that slope. For a demand curve, the slope is negative. For a supply curve, the slope is positive. With that rudimentary idea about how to write the equation of a straight line and how to draw that equation of a straight line in a graphical setup, let us now move on. Usually demand curve and supply curve are given as a function, where a demand curve is basically a function of two variables, quantity demanded and price. The way we write a demand curve is that we tend to think that our quantity demanded is a function of price. This is the general convention of how demand curves were originally written. Things got crazy when people started putting this equation in a graphical setup. About 200 years ago, about 200 years ago, the guy who came up with this mathematical formulation for a demand curve realized that it is very difficult to really represent that equation in a graphical setup. It doesn't make sense. If you look at this equation, you might think that QD is Y and this is M and P is X, right? Right? And you would try to draw demand curve that way. Marshall, the guy's name is Marshall, about 200 years ago, realized that it really doesn't make any sense, because the equation seems to sort of suggest that whenever price changes, your quantity demanded changes. And it seems like once you know the price, you can find the equilibrium quantity. You put substitute the value of P on the right hand side, you get your quantity demanded. But graphically, it makes more sense to think about demand and supply in terms of price, meaning that in our market analysis, we want to find out the price first and then we find the quantity. I understand that this might not seem like a big deal, because it is not. For a more advanced level, the way Marshall drew the equation of a demand curve and the way he wrote the equation of a demand curve and the way he drew the equation of a straight line of the demand curve are fundamentally different. So basically what we want to draw the demand curve is we want to draw the demand curve as the way I have drawn it. Notice that this graph and this equation are not the same. In order to get the equation of this line, we need to really write it as that. Do we all see that? Where we can simplify that a little bit. We can so the first term is going to be 4,750 divided by 1,000 plus QD divided by 1,000. So if we write it like that, notice that this looks very much like a C, this looks very much like an M, and this looks like your X, and this looks like Y. And now it makes sense, right? Now P is your Y-axis variable, QD is your X-axis variable, and the demand curve is drawn as follows. So that's how the demand curves were written, but then they were drawn in a certainly different way. So the next one is to think about the supply side, right? The supply side is again the same. So you have quantity supplied defined as a function of price. You can see that the supply curve has very much everything that a demand curve has, with the exception that their vertical intercepts and their slope looks a little bit different. So once we draw this according to the way Marshall drew the demand curve and supply curve, we can pretty much get our standard demand and supply curve pictures. But we are not interested in pictures now. What we are interested in is how to solve market equilibrium from a mathematical perspective. In our graph, we have learned that equilibrium is found where demand is equal to supply, which means that a point where demand curve intersects the supply curve, we find a common quantity that the buyer is willing to buy and the seller is willing to sell, and that is what our equilibrium is. And we therefore can find market equilibrium by equating quantity demand with quantity supplied, where we are going to substitute the value of quantity demand on the left side, we're going to substitute the value of quantity supplied on the right hand side. That's how they do it. Notice that this is a sort of like a linear equation. This is not a system of equation, just one equation where the only unknown is P. Everything else is given. Do we all see that? Once we solve this problem, we find our unknown, which is P. P is actually our market equilibrium price. Once we find the market equilibrium price, we can substitute that back to our quantity demanded. We are going to get the quantity demanded in market equilibrium. If we substitute that back in our supply curve, we are going to get quantity supplied in market equilibrium, and they are going to be identical. Which means that in market equilibrium price, the quantity that our buyer wants to buy is equal to the quantity that our seller wants to sell. We can really verify that. If we substitute the value of P in our demand function, we find that our quantity demanded is 2,200, this big number. When we substitute that back in our supply curve, we find that the quantity supplied is identical to quantity demanded. So we have indeed found the market equilibrium quantity. Our market equilibrium quantity is the one that we have just derived. So we have found market equilibrium price, 2,500. We have found market equilibrium quantity. So without drawing a single graph, we can pretty much find everything that we need to find to calculate and learn about market equilibrium. What we have just shown is that without drawing a graph, we can figure out what the market equilibrium price and what the market equilibrium quantity is. Now, we can derive further results based on these mathematical equations. For example, we now need to really draw our demand curve. In order to draw our demand curve, notice our demand curve is like that, and we need first the vertical intercept. What is the vertical intercept? Vertical intercept is the price where output quantity demanded is 0. Do we all see that? Vertical intercept of our demand curve, when the vertical intercept is measuring price and horizontal intercept is measuring quantity, our vertical intercept, which is this, is when QD is equal to 0, right? Do we all see that? Our vertical intercept? You have to sometimes give me some kind of feedback, without which I get nervous. The thing here is where the government is putting a price ceiling on the rental facilities of 1,500. So the government is saying that the rental price cannot go up over and above 1,500. In the last couple of classes, we have argued that whenever there is a price ceiling like that, this creates black market. First of all, once we know what the price government forces the sellers to charge, we can substitute that value in the supply curve, and we can find QS at which the price is $1,500. So QS, when the government forces the sellers to charge $1,500, is actually 950,000. Do we all see that? So at 1,500 price, the maximum number of housing units our producer will be willing to sell is 950,000, and that's this point on the demand curve. We now want to also find out the price that our buyer is willing to pay. And the price is much higher than what the producers are charging, because we have shown in the previous classes that whenever there is a price ceiling like that, there is a black market where the buyer actually ends up paying a very large black market premium to get the houses. How do we get P1? We know that our buyer is forced to buy 950,000, right? So we go to his demand curve. We know that the amount that our buyer will be willing to buy is 950,000. We plug in that back and we find the price that our buyer would be willing to pay to get that. And that price is 3,800. So our P1 is actually 3,800. So we have just identified the various aspects of welfare loss when there is a price floor. Price ceiling. Why do I always say that? Price ceiling. Right? From our previous discussion, we have shown that this triangle is the deadweight loss. The upper part of this triangle is the loss of consumer surplus, and the lower part of this rectangle is the loss of the producer surplus. If we can calculate the area of this triangle, we can calculate deadweight loss. The only thing that we need is a measurement of the height of this triangle, where the height is nothing but the difference between this and that. So it's 225,000 minus 950,000. So that's my height. And the base, which really is this difference, is 3,800 minus 1,500. Once we find the height and the base, we should be able to calculate the area of this triangle, which is our measurement of deadweight loss. So if we do the calculation right, you will find that the deadweight loss is 840 million. The units are irrelevant. What is important is whether you can calculate that. So, by using mathematical formulation without even drawing a single graph, you can literally calculate deadweight loss. You can find a numerical value of the deadweight loss. You can find the equilibrium price. You can find the equilibrium quantity. I'm still debating on whether I should have this in your exam. This is very surprising. This might surprise you, that why did I spend so much time going over this if I'm not planning to have this in the exam? The answer is very simple. Many of you will end up taking intermediate microeconomics. Some of you will take public finance. Some of you will take international economics. And the analysis that we just carried out today, first the tax incidence analysis, and second the mathematical formulation, will show up over and over again. And based on my experience teaching these other courses, I know that people struggle with this very simple mathematical formulation. So I wanted to cover that. Okay. In the next class, so we are ending our class today early. So I'm going to upload the next quiz and next homework today, and it will be due on Monday. It will have 2 chapters. Thank you very much. On Friday, we are going to start the next class.